Thank you very much. So, I would like to thank the organizers for inviting me to this meeting. It's a tremendous opportunity for us in Chile to be part of this huge effort. If it comes comes into place, we have been learning a lot. In fact, one of the main things that has already come up and benefit the geoscience community in Chile is this approach and the thinking that we have been somehow forced to somehow forced to think about the questions, and if we had the opportunity, the resources to come up with some ways on how to observe certain aspects of the phenomena in Chile, how it would do it, it's been a tremendous opportunity, and this is given by the AndesNet. Is a result of a collaboration in Chile. Oh, yes. This one. The AndesNet is a collaboration that results of a meeting that we had in Termas El Corazón in Chile, and that when representatives of SZ4D came down to Chile, and we gathered about more than 70 representatives from different parts of the community, geoscience community in Chile, that were interested in be part of this effort. And we took that group of people that in that particular meeting, the main questions were to introduce the SZ4D concept and relevance for Chile. They identify some scientific needs of Chilean geohazard research. That is very important. That geohazards is involved, and then there is a tremendous change in Chile that took place after the large earthquake in 2010, the Maule earthquake. There are several monitoring agencies were charged with more funds to carry out their mission in a better way. But we will go that later in the talk. This is just an introduction on how AndesNet has been formed, and this is a counterpart for this AxelNet network of collaboration, international collaboration. That picture shows. That pictures over there shows the results of the people participating in this meeting. Then it continued this with an invitation to form this AndesNet with lots of interested people participating. And the nice thing is that this was the first time that geohazard people working in Chile, local scientists, gathered together, and we could talk about the different aspects that we thought important. And this AndesNet is giving the opportunity to continue this collaboration. These are the details of the AndesNet participation is there. And after one meeting that we had last week, November 9th, it came clear that there is a lot of interest in continuing with this effort. Let me see. This is the one. What I was telling you about I was invited to talk also about the monitoring effort, the infrastructure, the existing infrastructure in Chile, about monitoring these different phenomena. There is the civil protection system in Chile is only a coordination effort, a coordination agency, and it relies on several of these units that are independent. These are the ones that are listed. What the names of these agencies are, and they are independent of this civil protection agency. Now it's called SINAPREDI. It's very interesting. This is has been the new one. The agency changes name and goals and activities from January 1st next year. There is a tremendous change in the way on how natural disasters and catastrophes have been dealt with in Chile recently. There is a new law. This law recognizes territorial bodies as it has been in charge of doing lots of other things. And these are the agencies I was telling you about. The tsunamis. This is volcanoes, is the Chilean Geological Survey and Mining Service. This is forestry for forest fires. This is water. This is for floods, and this is for rains and meteorological agents, meteorological aspects. These are the recognized bodies that will serve as servicing the new system that is called SINAPRED. In Spanish is Prevention and Disaster Reduction Agency. CSN, we are here. This is the National Seismological Center of the University of Chile. This is the Hydrographic Institute and Service and Oceanographic Service of the Navy in charge of, and I will talk about these three units only. This it's the maybe this way. Oh, it doesn't go. Okay, sorry. There we go. There we go. This is just we can skip. You know probably better than I do the conditions of Chile. This is the more important aspect is that Chile in general. This is if we take the let's say last 450 years, there is another, as an average, there is one earthquake of magnitude 8 or over every 12 years, roughly. So in fact, in the last 10 years, we have had 2 of them. After Maule, there is an 8.2 and 8.3 in northern Chile and north central Chile that have taken place. And when these are large enough, they produce tsunamis that on the average, they take place every 30 years, roughly, or 4 meters or more. If you take tsunamis of 10 meters or more, it's about 60 years, the recurrence. So it's a very active country. And for that, we have a monitoring system that works together with the Civil Protection Agency and the Navy unit. This is just a cartoon that shows the location of the very large earthquakes that have taken place in this century, and they roughly represent the lengths of rupture or the rupture lengths. And here is a description of volcanoes. Where are the volcanoes more concentrated? Where exactly the most populated area of Chile is over here. Is in this along this region of always fading out. Is along this region, and from 33 degrees to the south, roughly up to 40, 42 or 43 is people are is a concentration of people in Chile. This is maybe this is the seismological observation system. This is we have on the left-hand side we have about 110 stations that are 6 component stations distributed along the country like that way. There is a concentration in the central Chile because of there is Santiago, and there is a fault that has been sort of categorized as active fault right next to Santiago, so that there is a concentration of stations there. But in northern Chile, there is a large effort that started before in mid 2000, 2006, 2007. The IPOC effort is a German-French effort that installed this very nice and very unique system of monitoring. These are the yellow circles in northern Chile, and we complemented in the mid 2010s with the blue stations. So the complete system has been working in northern Chile, IPOC, with since the mid 2000, and the rest, the blue ones, have been working operating from 2015 ahead, roughly 2016. There is additionally there is a GNSS effort we installed this GNSS with this capability of RTX that are sending data 1 sample per second in real time of position. So with an error of about 4 centimeters, that's what we have been producing. And the right-hand side shows the strong motion network that is independent, is additional to the left one, the left-hand side. It's a strong motion that were originally offline and were for civil protection purposes, for civil engineering purposes. And now we are putting them online and recording it continuously because some of them are still on trigger mode. All this data is recorded. Like this is an example of a station. We learned from the installation of 10 IRIS funded a very nice project of 10 stations to put in Chile, the geophysical observatories in Chile after the 2010 earthquake, and we learned from how to install the stations following that model, and we're doing the same thing here. The seismic analysis office in the University in Chile in Santiago is chosen like that. This is the result of the magnitude 3 earthquakes that we and above that we report every month. This is our monthly report. About 600 earthquakes magnitude 3 or over in Chile per month. That's what we report about. That's about 20 a day, roughly. We have the accelegraphic network produces this fantastic data that you can download all this data from EBTDB, which is down there. Oops. We have about more than 12,000 records since 2012. When these networks start to operate. So this is a fantastic network for civil engineering, as not only for civil engineering, but for other purposes as well. The GNSS records show you some of the records that we have had after 2014, when we installed the first instrument that had this capability and worked excellently. This shows about 30 centimeters of displacement on east-west for a 7.7 earthquake. It's in the subduction zone, in the contact zone, and here we can even see some 6.9 in the east-west component. Here you can see for larger earthquakes, the signals are more clear. You can immediately report back not only the size of the earthquake where have taken place, but also the distribution of displacement, of slip distribution along the contact zone. This is what we have been working along, and looking in the future, we have a fantastic project with Diane Rivet on using the fiber optical that a local company has installed in Chile in a submarine way. So we have made some tests, and now we are continuing with, and this is a result of, this is a result of the one earthquake, by 5.7 earthquake that has been recorded with this cable that is underwater cable that has been deployed in here. So we are now at the end of this year, we're deploying permanently a couple of more of these DASes, so it can be used for as a backbone for the SZ4D as well. The tsunami warning system, it depends on the hydrographic and oceanographic service of the Navy, and they have roughly about a bit more, maybe 43, I think, 43 tide gauges distributed along the coast of Chile and in the islands. These are two in the islands in here, Plus, in addition, they have deployed 5 buoys, 5 pressure sensors with that are, but for our purposes, unfortunately, they are on the other side of the trench, on the western side of the trench. So it's mainly to detect incoming anomalies in the pressure waves that are coming from the western side. This has produced some fantastic records of both the pressure sensors as well as the tide gauges, but fantastic records of the earthquakes that have taken place locally and abroad. And this is an example, for instance, for example of what? Excuse me. Let me go back. This is the tsunami produced by the Tonga event in Caldera. It's a very large anomaly that was recorded in the and it translated. This is about more than 5 centimeters, and it translated into 2 meters at the coast. 5 centimeters in the pressure gauge, translated into 2 meters. And this was used an example because Tohoku had produced roughly in Chile, in the coast of Chile, the Tohoku earthquake produced roughly the same anomalies. So it was a signal on to be careful along the coast of the country, and that was used to. And the volcanic network. This depends on the Chilean Geological Survey and Mining Service. It's after the Chaiten earthquake in 2008, the Chilean government decided to increase the capacity to monitor volcanoes, and since then they have produced, they have generated this network along different the volcanoes in Chile that have produced a tremendous advance. Before that, there were only two volcanoes monitored, and now there are 45 at this moment. These are the slides of the tsunami warning system were provided by Carlos Zúñiga, a commander, deputy chief of CHOA, of the Oceanographic Service, and these slides were provided by Álvaro Amigo, who is the head of this effort at Cernajiomín, at the Chilean Geological Survey and Mining Service. It gives an idea of where along latitude. This is the central volcanic zone. This is the southern volcanic zone and the austral volcanic zone. So and most of the population in Chile is located along this system. So these all eruptions have a tremendous impact on the lives of people in Chile. There is a ranking of volcanoes in order to monitor them with the amount of different instruments, type of instruments, number of instruments, and this is the 14 top 14 are the ones that are considered the most dangerous. So they would have a very high specific risk, so they are very closely monitored. And in total, I told you there are 45 volcanoes monitored at this moment. The distribution of these volcanoes is in these the different colors. Red is category 1, that is the same category as in the previous slide. So it tells you that there is some infrastructure along northern and central Chile, but there is nothing in the austral part of the country, nor in the islands. Therefore, an effort has to be done there. This is the way on how they are recording different aspects, seismology, there is I cannot see very well geovolcanology and the different ways on how to support this operation. In total, there are more than of the order of 60 people working on this effort in Temuco in central south Chile. This is producing being monitored 24/7 and producing reports. And in fact, Alvaro Amigo was supposed to be here, but he could not come because there was a sort of an alert in one of the volcanoes, in Villarrica volcano in south central Chile. This is the type of instruments that are being installed. I put it all this not for you to read, but to keep it in the report. The number of instruments that are like of the order of 180 instruments, seismic instruments monitoring these volcanoes, these 45 volcanoes, and around 50 GNSS instruments, tilt meters, geodetic sites, etc. The details, Alvaro can let you know which volcanoes are monitored in which way. There is also a tremendous effort in education of the people on how to react on this with drills and simulations, so people would know what to do during this in cases of emergency, in cases where there is a need. Same thing with the tsunamis. It's amazing how people can react at this moment now, because if they feel an earthquake that is intensity 7 or over, they know that if they lose the equilibrium when they're walking, then the time that they have the recovery, the stability, they have to run to a safer place. And people are working on that. With this, I hope I have given you a brief summary, an overview of what we're doing in Chile, and the way on how all this infrastructure that is supported by the government, the government has a mandate to maintain information for the safety of the Chilean inhabitants. These systems will continue working and can be utilized as a part of the infrastructure for SZ4D. That is all the data, at least our data and the Navy's data is and part of the Sergio's data also is available to the users. So with that, I would like to conclude my presentation. Thank you very much for your attention.